So first part of the notes are things you should already know before you walked into this room. Classify triangles by their angle measures and side lengths is what we're doing in this section. And then we're going to use those classifications to find missing measurements. So first thing that's in your notes starts with just some basic information about a triangle. Couple of picky things about notation. When it talks about the sides of a triangle, it is talking about line segments. So if they say name the sides of the triangle, make sure you're using correct chapter 1 notation. Okay? Secondly, if we name a triangle, we will always put a triangle symbol in front of it. So triangle, and then you name it by its 3 vertice points. And the order in which you name those does not matter. You can name it ABC like they did, or you could name it BAC or CBA. Just always go consecutively in a circle when you're naming a shape. So it doesn't matter if it's clockwise or counterclockwise, but just go in a circle. A, B, and C are the triangle's vertices, plural. We were at lunch the other day, and Mrs. Seegert said, guess what? I got a new one on a homework. And it's not that we're making fun of our students, but sometimes we get some really funny answers, and so kind of, I guess we are, but she didn't say who the student was, so that helps. It's just a funny joke. So she said, hey guys, guess what the plural form of vertex is? And of course, we're all thinking vertices, or the wrong form, vertexes, and she says parabola. So that was a student's answer to the plural form of vertex, and so it was funny. That's funny, right? Parabola. I don't know. So anyway, funny things like that. Yes. I'll look at them in a minute, okay? We'll do it when we get to the end of the lesson. Okay. So I need to warn you, when you get to directions, I don't want the directions to be what defeats you. So when you get to the directions, if it says classify, then you're giving a name for the triangle based on one of two things. And it's really hard to read right here. It's either going to be based on its angle measures, or it's going to be based on its side lengths. So sometimes it's going to say, classify it by angle measures. If you give me a side length name, that's wrong. If it says classify by side lengths and you give me an angle measure name, that's wrong. So make sure you're careful, okay, that you're reading your directions. So there are a few angle measure names, and the first one is acute. So an acute triangle should have all acute angles, right? Acute means less than 90. So they should all be acute. They do not have to be congruent. They could all have different measures, but they should all be acute. All right, an equiangular triangle. Equiangular, one of the very most misspelled words besides dilation, is equiangular. It is not equal. There is not an L in between them. Okay? Equiangular. Equiangular means they're all equal, meaning every angle in the triangle is the same measure. Now, remind me what you already know about the sum of all the angles in any triangle. Adds to be 180. So if they're all equal, then what is each angle going to be? 60, because if you divide it by 3, you're going to get 60. So when they tell you that it's equiangular, or they mark that all 3 angles are equal, not only should you know they're equal, but you should be able to say that they equal 60 degrees. Okay? What's different? Oh, I don't know. Oh, not as thick? Yeah. All right. So we've got acute, we've got equiangular, and then we have a right triangle, which is going to have what? Okay, a box, a hypotenuse. It's going to have one right angle. It can only have one. Why can it only have one right angle? Okay, because if you have 2, what is that sum going to already be with just 2 90-degree angles? 180, but you need 3 to add to be 180, so it's impossible if 2 are already 90. So it's only going to have one right angle. And then the last classification is obtuse. Obtuse triangles are going to have one obtuse angle, and again, only one for the same reason. If it's greater than 90, there's no way you can have 2 greater than 90, or they wouldn't sum to 180. I do want to warn you that all of this that we are learning, and I don't think I ever said this back in August when we started school. Everything we're learning in geometry is considered plane geometry, meaning that it's two-dimensional on a flat surface. If we took this information and put it on a sphere, which is the world that we live in, if I were to draw a triangle on a sphere, it would not be the same as drawing a triangle on a flat two-dimensional surface. So the properties we're learning about triangles in plane geometry would be different than the properties we would learn if it was spherical geometry. So you may have courses in your future where your professor talks about spherical geometry versus plane geometry, and we won't talk about spherical geometry in here. So I just want to warn you that some of the things you're learning would be different, okay? All right, so just throw that out there. Okay, so then you're going to have some problems where you have to classify triangles based on their angle measures, which should be simple, except they're not always going to give you all the measures, and you're going to have to figure out what they are to make your decision. If it says classify, though, remember you're telling me acute, right, obtuse, or equiangular based on angle measures. So we want to look at triangle BDC. What is triangle BDC going to be based on angle measures? Mm. Mm-mm. Nope. I can't change the color for some reason. Look at this triangle. BDC. What is the measure of this angle right here? What's the measure? 100. If I have a 100-degree angle, what kind of triangle do I have? Obtuse. The 90 is for this whole angle, but we're not going all the way over to here, right? So this is obtuse. Be careful. Okay, let's keep going. Triangle ABD. ABD. Okay, so let's look. We know for sure this angle A is 80 degrees, right? And this angle D down here, ADB, is 20 degrees, right? Which means this other angle has to be how much? 80, because together they have to add to be 180. Or if you didn't remember that, these two angles are what kind of angles? Linear. So together a linear pair should add to be 180. So you need to find the missing angle before you make your decision. Don't just make it off of two measures, because what if your third measure is obtuse? But it's not. 80, 80, and 20 are all less than 90, so my answer is acute. All right. So then the next classifications will be by side lengths. And again, watch your directions. If it says to classify it by both, then you're going to have two names. One for angle measures, one for side lengths. And again, you should probably know these already. Equilateral does have an L. It is equal lateral, or you can think about it as equilateral, but it has an L there. Equiangular does not. Equilateral means all the sides are equal. So notice all the tick marks. Isosceles, oh, another one that's easily misspelled. So there's an S and a C side by side. That's the biggest thing that usually is messed up with. Isosceles, maybe. I don't know how that'll help you. But isosceles, make sure you can spell that correctly. Here's the thing that a lot of students get wrong. Isosceles is not just two congruent sides. Isosceles is at least two congruent sides. So if it is equilateral, it is definitely what? Isosceles. If it's isosceles, it could be equilateral. Okay, so it is kind of, be careful. Always, sometimes, never. Those would be great questions for me to ask you. An equilateral triangle is always isosceles. Isosceles is sometimes equilateral. Okay, so at least two congruent sides. And then we have scalene, and scalene has no congruent sides. So again, we could mark that with three different tick marks. And those are your only options. So it's either scalene, equilateral, or isosceles. Okay, when you look at a figure, do not assume anything about your figure. You can only base your answers or your decisions off of the markings. Do not look at it and say, oh, it looks like it's a right angle. If it's not marked a right angle, you don't know it's a right angle. Never assume. They will purposely draw the figures not to scale, just to make sure you're using the markings and the information in the picture. Okay? So classify by side lengths. This time we're looking at EHF. What is EHF going to be? EHF. Yes. So that means this is 10 and this is 10. So it has two congruent sides, which makes it isosceles. I-S-O-S-C-E-L-E-S. Isosceles. Okay, so it's isosceles. Go to the next one. Yeah, it's got a lot of information that's different because we got to check that you know what is the difference between isosceles, equilateral, scalene. But it's not hard. It's super long. Okay, so find the side lengths of triangle JKL. It says find the side lengths. Be careful. Part plus part equals whole is about angle measures or line segments. So look at your picture first of all. What kind of triangle do we have? It's isosceles. It's got two tick marks that are the same. So what does that mean about this expression compared to this expression? They're equal. So look and see, what do I know about them, and then set them equal and solve for the value of x. So 4x minus 10.7 equals 2x plus 6.3. All right, tell me what to do here. Subtract 6.3 is fine. So that gives me 4x minus, careful, they're both negative, 17. So 4x minus 17 equals 2x. Now what? It's okay. So subtract what now? 4x. So now we have negative 17 equals negative 2x. And then what do we want to do? Divide by negative 2. And so we end up with x is equal to positive 8.5. Okay, that's not our answer though. That is just x. What did they want us to do? Find the side lengths. How many different sides does our triangle have? 3. So you're going to have an answer for JK. Do I put a line segment above it? No. Never when you're using equals and giving me a number. Only when you're stating a segment's congruent to another segment. Never if you're talking about its measurement. This is distance from J to K. If you're just naming the side, yes, but not if you're telling me it's distance. Okay, we'll have a side length for KL. What do we know about JK and KL? They should be the same, right? So we don't really have to plug it back into both unless we just want to check and make sure we didn't make a mistake. And then we need an answer for JL. So do you care which one we plugged 8.5 in for? I would too. It makes our math a little easier. Yes, so 2 times 8.5 plus 6.3. You know, 2 times 8.5 is 17 plus 6.3. 23.3. So KL is 23.3, which means JK is also 23.3. And then we need to find JL. So now we're going to have to plug the 8.5 in for it. So 5 times 8.5 plus 2. And what is it? I'm sorry? Yes, 42.5. Good, Tyler. And 42.5 plus 2 is 44.5. And then circle all of those are your answers. Pretty easy? Okay, just look at your picture and decide, what do I know about it? What can I do to write an equation? Look at the next one. It's very similar. We just talked about that. When do we put a line above it? When we're trying to say that it is congruent to another shape. This means distance, and distances have numbers and measurements. If you put a line above it, you're talking about the shape. We're not saying the shape is 23.3. We're saying the distance from J to K is 23.3. If you are using an equal sign, you should never have a line above it. Okay? Okay, look at the next one. Tell me what's different. It's equilateral, so all sides are equal. Do we need to do anything different because of that? You can solve it 3 ways, actually. Ooh, be careful. I love that you said that, though, Ridley. One of the most common mistakes I see on a problem like this is exactly what Ridley just said. You could add all of these and set them equal to 180. What adds to be 180 in a triangle? The angles. But every year I have lots of students who will add the sides and try to say that they equal 180. Your triangle can get infinitely bigger, and those side links are going to get longer and longer. There is no sum that your sides ever reach. Your angles, however, will, no matter how big your triangle gets, your angles stay the same degree. It's just the length to get from one angle to the other gets longer. So those are still going to be 180 total, but not the sides. Okay, so back to how we're going to solve it. Okay, so we just need to pick 2. If it's equilateral, they're all equal to each other. So just pick 2. You don't need to use all 3. Pick 2 and set equal. Which 2 do you guys want to set equal? Okay, so 3y minus 4 equals 2y plus 3. But again, you could have used the 5y minus 18. So 3 different ways you could have set up those equations. How do you want to solve from here? Subtract 2y. So we have y minus 4 equals 3. Add 4, and so what is y? Y is 7. Is that our answer? No, because it said find the side lengths. If it had just said solve for y, you would be done. So watch your directions. So we've got how many side lengths? 3, but they're all equal. So GF, GH, and FH. And so we really don't have to plug it in 3 times. We can just plug it in once, and they're all the same. So where do you want to plug it into? I don't blame you. It's a little easier. So plug 7 in over here for 2y plus 3. What is 2 times 7 plus 3? 17. So all of them are 17. It's just there's a lot of problems on your homework. It's not a lot of writing. It's just that there's a lot of problems on the homework. But like this. Okay, so it's not terrible. No proofs. Okay, let's look at the next example. And now we're, yes, at word problems. So I want you guys to read this, and you and your partner take a few minutes and see if you can figure out the answer. So first of all, it says it was what kind of triangle? Equilateral. So that means each side was 18 feet. And so how many feet does it take to make one triangle? 54 feet total to make one triangle. And you have 420 feet of steel beam. So we're trying to put that steel around the outside to make the triangle. So I saw a lot of you doing 420 divided by 54, because that's how much you're going to need for one triangle. So 54 went in here how many times? 7 times 4 is 28. Carry your 2. 35, 36, 37. Is that right? Subtract, borrow from the 2. That makes that a 10 minus 8 is 2. Can't take 7 from 1, so borrow from the 4. 11 minus 7 is 4. So we have 42 feet left over, but we need 54 to make the next triangle. So we're only going to be able to make how many triangles? 7 triangles. Any questions? Okay, that is it. The next one is just another kind of problem just like it, so we'll just not worry about it. Any questions? That's 4-2. Pretty basic, right? Not terrible? But super important for where we're headed, guys. It's so important you understand the key words, vocabulary, and can apply them. So 4-3, now we're going to talk about these triangles, but we're going to talk about interior angles, exterior angles, and measurements and relationships and apply those to figure out other measurements in our picture. I don't think so. Yes. We are going to talk about auxiliary line here, but we won't really use it today. That's different. Okay? We're also going to learn what a corollary is, and if you haven't learned enough postulates and theorems, we're now going to have what are called corollaries. So same kind of thing. So lots of vocab. The first thing that's in your notes, though, is the triangle sum theorem, and you already know it. The only thing you may not know is that it's called the triangle sum theorem. You are going to have to memorize that because you will use that in a proof. Okay? So triangle sum theorem just simply says all the angles add to be 180. Okay? Triangle sum theorem. So if in a proof you need to say this right here, the reason you can say it is by the triangle sum theorem. I'm going to say that several times so it starts to stick in your head. Okay, I'm going to say again, we're going to learn this definition, but we're not going to use it today. We're going to use it later in the chapter. So it's important you pay close attention to what is an auxiliary line. An auxiliary line is a line that you add in order to write a proof. You are not allowed to add an auxiliary line unless it's the only way you could do the proof. Okay? Okay, so what I'm telling you is when you get to the proofs coming up starting tomorrow, you will not add auxiliary lines to every problem and start creating all these craziness. We're only going to do it rarely, maybe once or twice throughout the entire year. Only when it's absolutely necessary, and it'll be pretty obvious on the ones where you're like, there should be a line right here. And the way you do it, so add this in your notes right now, and when you get to that problem on the proof, you're going to look back at these notes. The way you do it in a proof, you have your statements and your reasons, and somewhere along the line, you're going to have to add an auxiliary line. So all you're going to write is draw, line, whatever you're going to call it. Maybe it's got 2 points and you're not going to put line at all. You're going to put the actual name of it, draw AB with a line above it. Or maybe it's going to be called line L and there's a little cursive L out to the side. But you're going to just simply put draw and then whatever the line is, and then your reason is going to be definition of auxiliary line. So hold on, let me write this down. The point is you could not do the proof unless there was a line in that picture so that you could continue using the information to get there. So, for example, let's say, which is where we're headed, you had a picture like this. And I said, prove triangle ABD is congruent to triangle CBD. You don't have two triangles yet, right? So you would have to draw what line? BD, right? Now you've got the two triangles. So in your proof, you need to say, draw BD, definition of auxiliary line. It's just a line you're adding to your picture to help you complete the proof. Okay, so this line that they've drawn in this picture is an auxiliary line for the purpose of proving that the angles in a triangle add to be 180. So what you could have done if this were your picture and you were trying to write that proof, you were trying to say, I'm going to prove to you that the angles in a triangle all add to be 180. You could say, I know that 4 plus 2 plus 5 have to add to be 180. Using the angle addition postulate. Part plus part should equal the whole. And I know that a straight line definition says it's going to be 180, right? So I could say these three angles add to be 180. Measure angle 4 plus measure angle 2 plus measure angle 5. That equals 180. Agreed? Okay. Then I could use this auxiliary line to create angles 4 and 5. And I could state that my auxiliary line is parallel to line AC. If that's true, then what do I know about angles 1 and 4? sorry, say it again. Their alternate interior. So then I could say that angle 1 is congruent to angle 4 by the alternate interior angles theorem. And eventually I could substitute 1 in for 4. I'd have to change it to an equality statement, but I could substitute 1 into 4. And then I could do the same thing for angles 3 and 5. They would be alternate interior. So then I could substitute 3 where 5 is, and eventually that would give me 1 plus 2 plus 3 is 180. And that would be how I could prove that the angles in a triangle add to be 180. I don't want to go through writing that formal proof out, but that's why we could draw this auxiliary line to help us. Okay? When we get to proofs, there may be problems that will be more like this for us, because we're going to be proving triangles congruent, not trying to prove the triangle sum theorem. So we'll be proving triangles congruent, and you'll see problems like this, where it's going to be obvious. Like, there is no way I can do that unless I draw a line here. Okay? So don't make it harder than it is, but I just wanted to set up what it would look like in your proof. Draw the line, definition of auxiliary line. That's all you have to do. Got fancy. Okay. So they like to make these problems applicable, but sometimes I think it's a stretch. So here's one that's kind of a stretch. After an accident, the positions of cars are measured by law enforcement. That's true. To investigate the collision. So suppose after our accident that this was the picture that the law enforcement came up with. Yes. So that would be maybe the place of one car and another car and another car and another car, because maybe it's like a major accident. I don't know. So they've created this diagram. That's the stretch, I think. But anyway, use the diagram drawn from the information collected. All they're basically, with all of that asking you to do is find the measure of angle XYZ. All that for nothing. All that for nothing. So XYZ, be really careful you're finding the right angle. XYZ, that should be super easy. How do we find that angle measure? Exactly. We know that all three angles should add to be 180. So 62 plus 40 is 102. And then subtract that from 180. And we get what? 78. Don't forget to put your degree symbol. Don't forget that you have a little m in front of your angle when you're giving me the measure. Any questions? Okay, so just 78 degrees. Moving on to the next one. This one wants you to find a different angle. Same problem, but different angle. What angle do they want you to find this time? YWZ. So YWZ. So now they're looking for this angle. Say it again, Edwin. So 62 and the one next. Okay, so 62 and WXY, this angle, are a linear pair, so they should add to be 180. So we can do 180 minus 62 is what? 118. So now we know this is 118. Did it give it to you on your picture? Okay, on mine it didn't. And it's important that you know that, because you'll have problems on your homework where you have to use it, okay? That's good. That's good, because then you thought of it automatically on your own. So this is 118. This is 12. So what are we going to do? Add them. And then subtract from 180. So what's 118 plus 12? 130, which means if I take that and subtract it from 180, we get 50. So the answer would be 50 degrees. I went really fast there. Is there any questions on that one? Okay, moving on. Well, your answer is technically measure of angle YWZ equals 50 degrees using correct notation. But for right there, we could just circle it. Oh, I'm sorry. Did I get it stapled wrong? I'm sorry. I'm sorry. Probably stuck it in the copier wrong. Okay, this one is too hard to see on your paper probably, or maybe you can see it but you don't notice these red markings. So I want to point that out, and then I'm going to let you guys try to figure out the answer. So do you see that this is a red arc mark and this is a red arc mark? Those are congruent. Okay, so make sure you got that marked, and then see if you can find the measure of angle MJK. Okay, Dennis, this is yours. Yeah, okay, sorry. What'd you get for your answer? Don't say it out loud.
Oh, that's not a big zero. That's a.
Okay, yes, you're correct. Perfect. Amazing. Get it, Alexa. You got a mistake somewhere. Uh-huh.
So then you subtract that by 136, that'd be 44, which is this angle right here.
Okay.
And those two are congruent, so this would be 44
Mm-hmm.
plus 44.
Careful, 4 plus 4 is 8.
Yeah.
A second. You're on the right track, but something's wrong. Okay, I'm going to pull you back up here because I'm going to try to get you quite a bit of time to start the homework, okay? So if we can, so we are going to keep moving. First thing you should have done was found this missing angle right here, 88 plus 48, and subtracted from 180. What did you get for this angle? 44 degrees. Everybody okay with that? That meant this angle was 44 degrees. And you add that to 104 to get those two angles, and we're looking for MJK. So that's this angle here that we want to find. So 148 from 180 should have ended with what? 32 degrees. Questions? Really? Everybody's good? Okay. So going on. Yeah, tomorrow we start. Okay, so I told you that today we're going to talk about corollaries. Corollaries are just another word for a short proof of a theorem. A corollary is a theorem. I used to say it was a theorem that followed easily from another theorem, and students would tell me, Miss Lashley, there ain't no easy proofs. None of them are easy. So I changed it from it's not a theorem that comes easily, but it comes quickly from another theorem. So a corollary is still a theorem. It's just a theorem. They call them corollaries because they follow directly and shortly from another theorem. Okay, and I'm going to show you a couple corollaries, but they are just another kind of theorem. So one of our theorems that we already figured out is this one. We did it without even talking about it as a corollary. We said that if all the angles in a triangle add to be 180, and then we find out that our triangle is equiangular, then that means every angle in the triangle is going to be what? 60. So this is a corollary, okay? It says the measure of each angle of an equiangular triangle is 60 degrees. So if you were working a proof and you knew first that you had an equiangular triangle, you would have to know it was equiangular, then you could go directly to, so this might be your statement 1, your statement 2 could be, actually, that's not statement 2. Your statement 2 could be this, that each angle is 60 degrees, and this would be your reason. This one doesn't have a name, and neither does this one. But that's, you can just say, I mean, just think about it. You don't have to really memorize it word for word. You're just saying every angle is 60 degrees in an equiangular triangle. That's all you have to say. Okay, just what you would normally think. Okay, same thing here. This corollary we haven't talked about yet, but it's kind of common sense. If we know all three angles add to be 180, but one of them is already a right angle, That means if I take 180 and take away the 90 degrees, what's left for the other two? 90. And what do we call two angles that add to be 90? Complementary. So it says the acute angles of a right triangle are complementary. So if you have a right triangle, the other two angles have to add to equal 90 degrees. Not necessarily. You could have a 30 and a 60 or a 20 and a 70. It just means that they add to be 90. If it was an isosceles right triangle, then those angles would end up being 45 and 45. Because if the sides are the same length, the angles across we're going to learn are going to be the same length. But for right now, you don't even really know that. Okay, so here we go. Looking at some more problems. One of the acute angles in a right triangle measures 2x. One of the acute angles in a right triangle measures 2x. It's a right triangle. What is the measure of the other acute angle? Be careful, don't make this harder than it is. What did we just learn about the two acute angles in a right triangle? They're complementary. So that means that 2x plus the other angle, what do we want to call it?
Y.
Can't call it x. X already has a value. So z or y, whatever. This is the other angle. What do we know they should add to be? 90.
So now we just solve for
So now we just solve for y. So what is y?
90 minus
90 minus 2x. And that's as far as you can go because you don't know what x is.
So that's it.
That's it. And you don't have to have y equals. You could just say the answer is 90 minus 2x. If you know one of the acute angles, the way you find the other one is to subtract it from 90. If it's a right triangle, the other two have to be 90. So if you know one of them, the other one is 90 minus that because they're complementary. So this is your complement, right? Okay. Next problem should be one with fractions. Am I correct? Okay. So you and your partner go ahead and figure it out.
show your art.
I saw it.
You don't need to see it.
I saw it.
Oh my. Because you're trying to solve for x. That's exactly what we just did here.
The only thing I would warn you about is what if this was like 3/7? Or, so you need to do it with fractions if it's not, okay? Come on, this is easy.
It's 2 divided by 5.
It's like, what? If you have two, I was going to say, if you have 2/5, you can't have a half. Okay, I'm going to pull this back and I'm going to show you some fractional help that you might need. So first of all, again, if you have a right triangle, the other two acute angles should be complementary. That's the kicker they're trying to get you to remember. It's a shortcut. So that you're not doing 90 plus 48 and 2/5 and then subtracting that from 180. That makes it harder. Instead, if it's a right triangle, the other two angles, so 48 and 2/5 plus the other angle should add to be 90. Which means to solve for the other angle, we're just going to do 90 minus 48 and 2/5. Okay, guys, subtracting with fractions, proficiency test. Don't make this harder than it is. Two ways you could look at it. One way is borrow from the 90 and make a whole out of your fraction. So if I borrow from the 90, one whole, what's that going to change this to? 89. Okay? I want to make this the other whole, but I want it to be out of 5. So 5/5. Then subtract. What is 5/5 minus 2/5? 3/5. What's 9 minus 8? And 8 minus 4. So it's 41 and 3/5 degrees.
Wow, that was.
Okay? Or you could say 90 minus 48 is 42, and then you need to take away another 2/5, which leaves you with 41 and 3/5. Okay? So whatever works in your mind, but don't make it more complicated. Make it easier. Okay? All right, moving on. So interior versus exterior, I would hope that you guys would know what that is, but interior you think of inside, exterior outside, okay? So these would be interior points, these would be exterior points. Okay? Here's the part that's super important for the rest of the lesson here. You need to know what is an interior angle, and you need to know that there are exterior angles outside of a triangle if you extend one of the sides out, okay? So yes, so angles 1, 2, and 3 would be considered interior angles because they're formed by two sides of your triangle. But 4 would be considered an exterior angle because it's formed by a side and the extension of another side. So if you extend it out, it's going to make an exterior angle. You can have an exterior angle at every vertex if you just extend out one of the sides. Oops. Sorry. Okay? So you could have an exterior angle at every vertex. Yes, sir?
Wait, why don't they do it like the opposite? Like if it's 30, the exterior will be like 130.
Okay, so you're saying, why don't we look at this whole angle? Okay, because in geometry we define an angle to be less than 180 degrees. We're looking at the smaller part of the angle, not the entire, and you're going to learn in trig or pre-cal when you take it, you will be talking about the whole rest of that term. Okay, so you'll talk about then, but for now we're talking about the definition for exterior means if you extend out a side, there is an angle that is formed. Okay, here's what's important. What do you notice about every exterior angle and its adjacent interior angle? Okay, they form a linear pair that makes them supplementary, which makes them add to be 180. Every interior and its adjacent exterior. Everybody agree with that? That's important. Okay, next vocabulary word. This one is going to be big for our next theorem that we're going to look at. Remote interior. When you think of remote and not what you hold in your hand to change the channel, okay, what do you think of when you hear the word remote? Far away, away from other things, okay? So that's the remote we're talking about here, not change the channel remote, okay? Yes. So remote interior is talking about the angles that are inside the triangle but are the farthest from the angle you're looking at. So in other words, if I'm looking at angle 4 here, then the two remote interior would be the ones that are not adjacent to 4, 1 and 2. Okay? So a remote interior angle is an interior angle that is not adjacent to the exterior angle. Not adjacent. So 1 and 2 would be further away, not adjacent. They're called the remote interior. Okay, I'm going to help us develop the next theorem without looking at the next theorem. So don't turn your paper yet. Look right here. Okay, what do we know about the measure of angle 3 plus the measure of angle 4? Okay, why? Okay, linear pair theorem. They add to make 180 degrees because they form a linear pair. That's the linear pair theorem. Get that in your mind too. Okay, what do we know about the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3? They equal 180. Why? Triangle sum theorem. Get that in your mind. We're going to proofs and you got to know the names, okay? So linear pair theorem, triangle sum theorem. Okay, so here's what I would ask you. If they're both equal to 180, what property can I use? Transitive, because this is the same, this is the same. So now I could say measure of angle 3 plus measure of angle 4 equals measure of angle 1 plus measure of angle 2 plus measure of angle 3. Agreed? Okay. Good, Tyler. So notice I got 3 here, and I've got 3 here. So what could I do? Not transitive. Subtraction. I could subtract away the measure of angle 3. So subtract it away, and notice what we find out. The measure of the exterior angle 4 will always equal the sum of the 2 remote interior angles. Okay, I'm going to say that again because that is our theorem. The exterior angle will always equal the sum of the 2 remote interior angles. Not the one that's adjacent to it, but the other 2. Always. It does.
It's called the exterior.
It's called the exterior angle theorem. Okay? So, and that's what it says. It says angle 4 equals the measures of 1 and 2. That your exterior angle will always equal the sum of the 2 remote interiors. And we won't use it a ton, and then it's going to pop back up. So I'm warning you. It's one of those things that you need to memorize and really think about because it will pop up later when we haven't used it in a while. Okay? All right, so first example where we have to use it. And by the way, this 5x minus 60 is referring to angle BCD. Okay? So find the measure of angle B. What did we just learn using the exterior angle theorem about this exterior angle? Okay? It should equal what? Okay, the A and the B added together, or the 15 and the 2x plus 3 added together. So we should be able to say the sum of these 2 is equal to the exterior. So 15 plus 2x plus 3 should equal 5x minus 60. What's the name of the theorem again? Exterior angle theorem. Okay. So now simplify. What's 15 plus 3? 18. Plus 2x equals 5x minus 60. Add 60. So 78 plus 2x equals 5x. Subtract 2x. 78 equals 3x. Divide by 3. And I heard x equals 26. Good. And is that our answer? No, what's it want? Angle B. So the measure of angle B was equal to 2x plus 3. So 2 times 26 plus 3 is 55 degrees. Questions? All right, so that's exterior angle theorem. We're learning a lot of theorems today. Triangle sum theorem, they all add to be 180. If it's a right triangle, the other 2 angles are complementary. If it's equiangular, all 3 angles are 60. Exterior angles, always the sum of the 2 remote interior. But we're getting close. Okay, another one. Same exact process. Can we just set it up and not actually solve it? What would I write down just to set this problem up? Okay, I need to make sure everybody's with Edwin. The exterior angle should equal the sum of the 2 remote interiors, not the one right next to it. And we know when we see that little box that means 90 degrees, right? Everybody okay with that? Okay, I'm not going to go through and solve for Z and plug it back in, but you should be able to do that. You can, but not right now. We're going to move on. Okay, I'm trying to get you to the homework so you'll have a little bit of time today. Okay, and I think this is it our last theorem? Okay, Yes. So third angles theorem, I can promise you that you will use this theorem a bunch in the next couple of sections. Third angles theorem says if two angles in one triangle are congruent to two angles in another triangle, then the third angles must be congruent. Think about it. If this was 30, what's this angle that it's congruent to? If this angle is 70, what's this angle? And what do we know has to happen for all three angles? Have to be 180, so that means the only option for n is 80, which means t has to be also 80, and that means that they are equal, so they would be congruent. This lets us skip all of that work and just say if two angles are marked congruent to two other angles, then the third angles must be congruent. And it's the third angles theorem. So when we're headed, which is where we're headed tomorrow we're going to learn the long way to prove triangles congruent, and then starting on Friday, we're going to learn shortcuts. And no matter which day we're looking at, if we're trying to prove triangles congruent, we're going to need to say that their angles are congruent, and the way to do that could be third angles theorem. So once you can get two are congruent to the other two, you can say the third ones are congruent by the third angles theorem tomorrow. Yes, I just said it. It's amazing to me. All right, so is there two examples left? Okay, I want you and your partner to try to work the next two. Be careful that you use your algebra correctly, and we'll check them. You can't, no, because two things. One, you have to square root the number also. It's not just the square root of y squared. So what is the square root of 4? 2, but you can't take the square root of 6. So you always get your variable on one side of the equation and by itself before you take the square root. Only take the square root. Yes. Oh, careful. You're moving it from one side to the other, so you're using an opposite operation. I'm coming around, so don't hesitate to ask me if you have a question. Close. Careful, you only have one pair of 2's.
Oh, so you have to be just 2.
Just be 2. But when you take the square root of both sides of an equation, how many solutions should you be getting?
Square root of 2.
You can't do that. Again, back to algebra 1. If you have something squared, you don't take the square root until that is all that's by itself. 2 is not being squared. -2 is not being squared, so you're not ready to take the square root. You've got to get what's being squared by itself first. So you have to divide. Yes, but remember when you take the square root, you should be getting 2 solutions. Okay.
So, no, there is on 2, it's in, and then 2 at 5.
Like after plugging it back.
Why are you plugging it back? Okay.
I think it'd be,
Okay, so you're doing fine. Plug it back in.
yeah, so yeah, I think it'd be 20, right?
So now square.
Okay.
You're squaring the 2, and you're squaring the square root of 5.
Okay. So,
I don't know, that's why I asked this last year to come.
Are we having some trouble on the first one? Yes, you'll need to plug it back in. Okay, come back up here. Everybody together right now. So first of all, what theorem are we using for this problem? Third angles. Because if we separate the two triangles, this one has F congruent to I, and then in this big one here, we have G is congruent to, in this big one, H, right? And I would warn you to think about that when we get to tomorrow, that sometimes you need to separate them from the picture and remark your picture. And we'll talk about that when we're doing our proofs. But we do have two angles in two triangles marked congruent, so that means our third angles must be congruent. Okay, so you started with that and you said 4y squared has to equal then 6y squared minus 40. Remember, when you are trying to use square roots, you have to have what's being squared by itself first. So that means you need to subtract the 4y squared so that we have 0 equals 2y squared minus 40, and then add your 40. So that we have 2y squared equals 40, and then divide by 2. Did you get as far as y squared equals 20? Okay, so from there, two things. One, if the question had said find y, then when you solve this, you have to make sure that your answer is in simplest radical form and that your answers are correct. So you would take the square root of both sides, and I saw several of you not doing this. Remember that when it is quadratic, how many solutions are you supposed to get? 2. So this should be plus or minus the square root of 20. If it had just said solve for y, you would get it wrong if you didn't put plus or minus. Then you need to simplify your 20. We talked about simplifying radicals. That's 4 times 5. The square root of 4 is 2, and the square root of 5 will not simplify. So we have plus or minus 2 square roots of 5. Everybody with me there? Can y be negative for this geometry problem? Yes, it can. If you plug in a negative number here, what's going to happen when you square it? It's going to become positive. So you have to be careful. Variables can be negative, just like on the test when you got a negative 3.75. Variables can be negative, but the angle measures can't be. So when you go and plug it back in, if it gives you a negative angle measure, that's when you don't include it. If it gives you a positive angle measure, you're good. So this would be your answer if the question had said solve for y. Is everybody okay with that? Okay, so two things. One, it didn't say solve for y. It said find the measure of angles k and j. So if it makes it easier for you, you could leave it as square root of 20 when you substitute it in. I'll work it both ways to make sure you see how to do it, because you're going to have to be able to do that in Algebra 2. So when I plug it back in, 4y squared, I could either leave y as the square root of 20, which will make it a little easier. Keep in mind it doesn't matter if it's positive or negative, because when you square it, it's going to be positive, right? So I'd get the same answer whether I put in a positive or a negative here. What happens to the square and the square root? They cancel. So I have 4 times 20 is 80. So the measure of angle K is equal to 80 degrees. Okay, but you need to know how to plug it in square root form, simplified, because you'll have problems that get harder later where that happens. So let's practice that. So if I have 4 times 2 square roots of 5 squared, the most common mistake I see is students going, oh, the 2 and the square root cancel, so this is 4 times 10, and that's 40. That's wrong. 2 square roots of 5 squared does not mean just square the square root of 5. It means 2 square roots of 5 times 2 square roots of 5. Or you have to square the 2 and square the square root of 5. So you would have the 4 out front. 2 squared is 4 times, and then the square and the square root cancel, and we're left with 5. And 4 times, what's 4 times 5? 20 is 80. Okay? For now, that's okay, but you're going to have problems where you have to substitute in things like that. So are you guys with me that 2 square roots of 5 times 2 square roots of 5, another way to think about it would be, that is 2 times 2 is 4, and square root of 5 times square root of 5 is the square root of 25, and the square root of 25 is 5, so 4 times 5 is 20. So then we got 20 in here. Okay? So somehow you got to be able to do that. But if it's not your final answer, you don't have to simplify your radical. And when you get to calculus, you won't simplify radicals. Mrs. Stinnett will tell you, oh, it's a good day, you don't have to do this anymore. Because in calculus, the numbers get so crazy that they do not simplify radicals. They plug those in and use their answers in unsimplified form. Okay? All right, last one we'll just talk about real quick together. Make sure you could have set it up and solved it. That was the hardest.
P and
So what would you have set up here?
2x squared.
Okay, and what theorem are we using?
Third.
Third angles theorem. All right, so here we could subtract the 2x squared to get 0 equals 2x squared minus 32. Add the 32. And I do that just so I don't have negatives. And then divide by 2. So x squared is equal to what? 16. This one turned out so much easier because when we take the square root, what is x? But it's actually plus or minus 4. Again, I would ask you, can it be a negative in our problem? Yes, because we're going to square it, so it would work. So if it said find x, you would put plus or minus 4. But since it doesn't matter when we plug it in because we're going to square it, the actual answers for P and T, it won't make a difference.
I like having the x on the side now.
Mm-hmm.
So I feel weird now.
Yeah, if it's not,
Just switch.
try to flip it. Yes. That's symmetric property though, right? Okay. So 2 times 4 squared gives us 32 degrees. So each angle would have been 32 degrees here. Okay. That was a lot of information.